Okay, Assalamualaikum and good morning. Okay, so basically this is just about Huffman code, which is under greedy algorithm, one of the techniques under greedy algorithm, and also under graph theory. Okay, graph, what we call graph algorithm. Okay. So under this graph algorithm, we have another one, which is greedy algorithm. And for this video, we focus on the Huffman code. Okay. So Huffman code is basically, we're going to use it for data compression, data encoding. Okay. Why? Because when we want to transfer a file, basically we want to find the optimum way to transfer a file or a message. Okay. Optimum means here is like a computational cost is very effective. The time is also very effective. Okay. So basically HUFFMAN code, we will use it for the transferring message, and also wait, where is my show presenter? Okay, for transferring message and also for image compression. Okay, but at the same time, we need to make sure that the file quality is not is still maintained there. Okay, for example, like we want to transfer this file, okay, in JPEG, and also, okay, let's say we have in PNG, but in PNG the size is very huge. So in order for us to transfer or to store this file without without omitting their quality, we compress it into JPEG. Okay. And other than that, let's say you have one file that a very secret file. So you want to transfer this file, but you don't want other people to know what is the message inside this file. So you can use Huffman code to embed that message, and the other people will not know what is the message in that file. Okay, only the receiver will know it. Okay. Other than that, we can use it for the, let's say, for the security purpose. For example, like watermarking. So you have a file, you have image file in uh, MRI, okay, MRI file for example. So you can embed there the message or the watermark inside that MRI file, in order to avoid any people do tempered into that file. Okay, so basic about the Huffman code. Before we go to Huffman code, let's say we have here message. We have this message that we need to send this message in a file to the receiver. Okay, so we need to store this in a file and send over the network. Okay. Therefore, we need to know the cost or the size of this message. And as we know that in computer, they measure this one in a bit, okay, in a bit, okay. So we need to know the cost, the size of this message in bit, okay. Okay. So in bit, in computer, computer use ASCII code. Okay, ASCII code. So let's say here we have this message. The length of this message is 20 characters. So we want this message in character, and we convert it into the ASCII code. And in ASCII code, it is 8-bit. Okay. So for example, this one, decimal 65, symbol A. But binary code for this symbol is this one. So this one is in 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8-bit. Okay. So we have A, B, blah, 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 until Z. And then we have another operator here, another. Okay. So all of these are in the ASCII code. And it is in the 8-bit. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, okay, before we go further on the Huffman code, we get the idea first. Okay. So we have this message. Okay. Basically, this message contain 20 characters. Okay, 1, 2, 3, 4, 5, 6, 7 until 20 here. Okay, 20 characters. So in ASCII code, one character belongs to have 8 bits. Okay. So 8 bits times 20 characters equal to 160 bits. Okay. So this is a normal size of this message without we doing any encoding. Okay. Masa ni kita tak buat lagi encoding. So the normal size for this message is 160 bits. Okay. So to get the optimum, in order for us to achieve the optimum way to send this message, we need to reduce the size by encoding it. Okay. The message only consists, in this case, our message only consists 5 character from the ASCII. 5 character means that we have B, we have C, 1, 2, A, and then we have D, and then we have E. So means that we only have 5 character, B, C, A, D, and E. So why we need to use 8-bit? Okay, because we only have five characters. So what we can do is we can encode it with our own code. We create our own code. So okay, go here. See here in the note here. Okay. Let's say we have 2 character. So for 2 character, if we convert into our own code, we just need 1 bit. Okay. A is 0, B is 1. So we only need 1 bit. Okay. But let's say our character is more than 2. Let's say we have 4 here, 4 character. So we need 2 bit because A represent by 0, 0, B represent by 0, 1, C 1, 0, D 1, 1. Okay. But let's say we have more than 4 character. We cannot use 2 bit. We need 3 bit. So let's say we have 7 character. So we need 3 bit. 0, 0, 0, A represented by 0, 0, 0. Okay. So go back to this message. We have character A, B, C, D, E. Okay. And here, since this character is more than 4, so we need 3 bit. So that's why we put here A is 0, 0, 0, B is 0, 0, 1, C is 0, 1, 0, D is 0, 1, 1, E is 1, 0, 0. Okay. Okay. So now we know that our characters in this message must be represented by using 3 bit. Okay, 3 bit here. So in order for us to create our own message, our own how the way to transfer that message, first we need to get the frequency of each character here. So frequency, okay, you go, the first character is character A. How many frequency? How many frequency in this message? A is 3. 1, 2, 3. B is 5. 1, 2, 3, 4, 5. C is 6. 1, 2, 3, 4, 5, 6. D is 4. 1, 2, 3, 4. E is 2. 1 and 2. Okay. So now we get the frequency, we get the code. Okay. So next, what we need to do is, we know that our new code for this character is 3. So our size of message will be 3 times 20 characters equal to 60 bits. Okay. So instead of, before this is 160 bits, now we have 60 bits. Okay. However, when we create our own code, computer will not understand it because computer only understand ASCII code in 8-bit. So how to make it? We need to provide reference. Okay, provide reference to read the new code. What is the aim of this reference? Reference means that we give to the receiver reference how to read our code. Okay, similar to like you want to introduce yourself to somebody, you need to give some reference, by saying that, oh, I'm from UMP, something like that. Okay. So, okay. So now, so means that when we create our own code, we need reference to let the receiver to read the new code. Okay. How to do the reference? Reference must be come from this. Okay. First, we see original ASCII code. Okay, original ASCII code for this message is 5 character times 8 bits because ASCII code, right? ASCII code dia ada 8 bit. Okay, 8 bit. So 5 characters times 8 bits we equal to 40 bits. Okay. New code kita ada 5 characters times 3 bits sebab kita guna 3 bits here. So equal to 15 bits. Okay. Therefore, size of reference is 55 bits because we add this one, ASCII code and new code. So, kita dapatlah 55 bits. Okay. Okay, 40 plus 15. So, we get 55 bits. Okay. So, now our size of message that we need to transfer to the receiver is, we have 20 character, right? 20 character times with the new code, which is 3 bits, equal to 60 bits. So, the total size of message will be reference plus message. So, our reference is this one, 55 plus with the size of message is 60. So, 55 plus 60 will be 115 bits. Okay. So, instead of we send 160 with our own code, we can send 115 bits. Okay. So, this one is our own code. But Huffman has another way to do it. Okay. So, how Huffman do? Huffman is actually, they try to find an optimum merge method by using greedy method that always select the optimum in each stage. So how Huffman do? Okay, first we need to order the character in note in increasing frequency. So we have here, we have character A, B, C, D, E, and we have the frequency here. So first we need to order it in increasing frequency. So the first frequency, the lowest frequency is E. So that's why we put E here, not 2. Okay, the frequency here, 2. And then we have the second lowest is A, okay, which is 3. So we put A here, 3. Next is D, 4. And next is B with 5. Next is C with 6 frequency. So we have here E, A, D, B, C. Okay, next step in Huffman code is it will merge to the 2 of the smallest node and make it 1. So we have the two smallest node now is 2 and 3. So we merge it, become 5. And then the next smallest is 5 and 4. So we merge it, become 9. Okay, 9 cannot merge with 5 because 5 has another 6 is the smaller than 9. So we need to merge this one first, 5 and 6. Merge it, become 11. And then we merge the another smallest, which is 9 and 11, become 20. Okay. So the idea of Huffman code is it will always merge it until at ending we will get the single node here. Okay, so you can see here this is a 3. Okay, so graph theory or graph algorithm always relate to 3. Okay. Okay. So now we already have single tree here. Okay. So what next is we need to mark 0 on the left edge of the tree and mark 1 on the right edge. So left edge, this one left. So we mark as 0, 0, 0, 0 and 0. For the right edge, we mark as 1. So this is right. Okay. So we mark 1, 1, 1, 1. Okay. Now we already get this 3. So what we need to do is we need to determine the code for each character based on this 3. So the code is come from 0, 0, 0. So sorry, A here. A 0, 0, 1. So we have 0, 0, 1. B is here. So we have 1, 0. C is here. We have 1, 1. D is 0, 1. D is here. 0, 1. E is here. 0, 0, 0. Okay, so now we get the code. Okay, we get the code for each character. 001, 10, 11, 01, 000. So no need to use all the 3 bits here, okay? Okay, so now we already get the code based on the Huffman, okay? Based on this Huffman, we get the total code that we use is 12 bit, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? For the message bit, for A, character A, we have 3 frequency. The frequency is 3. The code is 3. 1, 2, 3. So that's why 3 times 3 equal to 9. For B, we have 5 frequency and the code is only 2 bit. 1, 2. So that's why 5 times 2. And then for the C, we have 6 frequency with 2 bit, 1, 2. So that's why 6 times 2. For the D, we have 4 with 2 bit, 4 times 2. For the E, we have 2 frequency with 3 bit, 1, 2, 3. So that's why 2 times 3. So in total, for the message bit, we have 45 bits. Okay. Okay, but in the ASCII code, the bit is 40 bit because 5 character times 8 bits. So we have 40 bits. Okay, the same thing, we need to get the reference. Reference is come from this ASCII code and the code that we generate using Huffman. So we have 40 plus 12 bit. So, and then we plus with message size. Our message size is 45. So we have in total is 97 bits. Okay. So now when using Huffman code, we can transfer this message in a file with only 97 bits instead of before this. If without Huffman code and without encoding, we use 160 bit. But if we use our own bit, our own encode, we need to use 115 bits. However, by using Huffman code, we only need 97 bits. Okay, so how many percentage that Huffman code able to reduce the size? Okay, maybe around 30%, around 50% and above. Okay, so half of the bits, half of the size of the message, we can reduce by using Huffman code. Okay. So how efficient is the greedy Huffman in the greedy method in Huffman code? You need to find it. Find implementation code of Huffman code. What kind of implementation that we can use Huffman code? Okay. And then what is the time complexity of the Huffman code? So these are the questions that you need to find the answer. Okay. Okay. So that's all. Thank you.